Hello, this is Douglas Rumbaugh, and welcome to the third video in my introductory Python programming video series. So in the last video, we saw how we could use command line arguments to provide input to a program, but we really didn't do much with it other than just display it back again. So in this video, we're going to talk a little bit about actually doing stuff with that input, which means we are going to need to talk a little bit about how Python actually handles data and how we can manipulate data in Python. And that's actually a very extensive subject, so we're going to talk about it a little bit over the course of a wide range of videos. The goal here is we're just going to be fairly brief about it to try and get something functional and get you to a point where you can write basic functional programs. So just to give you an idea of where it is that we are going, we're going to write a very simple calculator. And this calculator will accept two numbers as command line inputs, and we'll add those numbers together. Fairly straightforward. So to show just an example of this thing running, I have written add.py. This is the program that we will be writing over the course of today's video. And this is going to accept two numbers, say 5.5 and 1.2, and will output their sum. So this is the program we're going to be working at writing here today. Without further ado, let's dive right into it. And actually, before I forget, let me do this. Might make things a little bit easier for you to see. Okay, so add.py. Now, again, this program is trivial enough that we probably don't need to spend a very long period of time discussing how to solve the problem. The basic idea here is we are going to need to get two command line arguments. We're going to need to add them together. And then finally display the result. Fairly simple process, although the most complicated thing that we've done up to now. So let's tackle each of these individually. The first one, getting the command line arguments, well, we know how to do that now, right? So first we're going to have to import the system module, and then we can get our two command line arguments with sys.argv1 and sys.argv2. So those two lines are going to give us our command line arguments. And now we need to add them together. And so here's where things can start to get a little bit hairy, because we need to reference these things, but we can't really do that without giving them a name first. So this is where this idea of a variable is going to come into play. I'm going to just type the necessary code first, and then I'll show you, or rather describe what it is that's going on with it. So let's create a variable called x and a variable called y. X is going to represent our first input, and y will represent our second. So here's how this works. X and y are what are called names. You'll often also hear them called a handle, especially in modern contexts. And these are nothing more than labels for some data. sys.argv1 and sys.argv2, as we have already seen, represent the input arguments to our program, the first and the second argument. So this name refers to some data, and this is the name that we are going to associate with this data. What does the association is this equals sign. So this equals sign is what is called the assignment operator. And the basic idea is it's going to take something over here and it will give that something a name. What name does it give it? The name right here. So as a whole, line 3 and line 4 are what are known as assignment statements. In fact, let me just go ahead and type that in here. They're assignment statements because they are using the assignment operator. This is the data that is being assigned, and this is the name that we are assigning the data to. So I'm going to ignore the next couple steps and just throw in some print statements here so that I can show you how this works. So I'm just going to print X, and then I'm going to print Y. So if I run this program, and let's say give it 4 and give it 8 as my two input arguments, we would expect to see, we would expect to see 4 and 8 get printed. And there they are. So because this sys.argv1 is the number 4, when I say x equals sys.argv1, what I'm effectively doing is saying x equals 4. I put quotes around it for a reason. We'll see that in a minute. X equals 4. So it takes the thing over here and gives it this name. Strictly speaking, this, the sys.argv1, or for that matter, 1, or for that matter, x, are all examples of a special kind of Python code called an expression. And so an expression is going to be anything in Python that you can evaluate to result in something called an object. What is an object? An object is data. So to sort of demonstrate this idea of an expression and how this works, I'm going to do something that I haven't actually done yet, and that is open up the Python interactive shell. So you can do this by simply typing Python and then not providing a program name. And this is going to give you a window that looks like this. So this is the Python interactive shell, which basically means that it's a Python interpreter, and we can type lines into it, type statements into it, one at a time, and it will evaluate those or execute those statements. For example, if I said print hello, it's going to print hello and then drop onto another line so I can type some more code. I could say x equals 4, or yes, x equals 4. So this is an example. Now print is a little bit weird because print stuff. So we would expect to see output here. Notice that when I ran this x equals 4 line, nothing showed up. So in general, when you evaluate a full Python statement in the interactive shell, you will not get any output, right? So a statement is a line of Python code that does something. In this case, what I did is I took the number 4 and I named it x. So if you type an expression, just a lone expression, onto the interactive shell, then the interactive shell will display the result of evaluating that expression. So as an example of a simple expression, x. The name x is itself an expression. What do you think that x will evaluate to in this specific context? Well, it evaluates to 4. And if I wanted to change what x evaluates to, I can reassign it to something else, say 9. Again, assignment is a statement. We see no output. If I evaluate the expression x, I just see 9. In addition to variable names, such as x being expressions, the number 9 is itself an expression. If I type 9, when I hit enter, it will evaluate. What's it going to evaluate to, you may well ask? 9. So this is a special kind of expression called a literal expression. It's a literal. It's a literal because it literally evaluates to itself. And we see in Python all kinds of literal expressions. So we can have a literal number like 9. We've already seen literal strings. Hello, this is text. The quotes tell us that it's text, and so this is an expression that will evaluate to the text hello. Nothing super surprising there. And as a matter of fact, we can take that hello, we can assign it to a name, say y, and now when I evaluate y, what will I see? Well, I will see hello. So we use Python expressions a lot. And that's the basic idea here. So over here, what we have is sys.argv1. This thing right here is itself an expression. It's an expression I can't really show you on the interactive shell because of the way that it works, but it's an expression. So what's this expression evaluate to? Well, sys.argv1 will evaluate to this argument, and sys.argv2 will evaluate to that argument. So we evaluate it to the first argument, and we name that argument x. We evaluate the second argument, name that thing y. That's what these two lines of code are doing. And now we can use x and y and the appropriate argument, 4 or 8, or whatever we happen to type, will show up in their place. We've named them. There was a lot there, so I hope that you at least somewhat followed it. Hopefully through exposure therapy, you'll get a fairly good handle on this idea. It's a little bit complicated, and I'm simplifying assignment a fair amount because we don't really care about the specific details of how this works at the moment. But that's the general gist of it, is we have an expression over here, which is some Python code that will evaluate to an object being data, the number 4, the string hello, things of that nature. And we take that object and we give it a name, x. And so then we can use that name anywhere we want to refer to our original object. So here we take the first argument, name it x. So now the first argument we type will be called x. So when we print x, we see that argument, as we can see here. If I were to do 7 and 9, or 100 and 101, or even hello and world, you can see that the first argument is printed first, the second argument is printed second, x and y. Okay. Now, we can assign the result of any expression to a variable. So let's create another variable, say z, and we want to assign to z the sum of x and y. So this is a program that's going to add these things together. So we want to calculate the sum and stick it in z. So how are we going to do this? Well, most math in Python is done using standard mathematical operations. So if I want to say z equals x plus y, I say z equals x plus y. So this is itself an example of an expression. It's going to evaluate to something. Let me show you. If I go back into the interactive shell again here, I can, for example, evaluate 4 plus 5. So this expression, I have 4, which of course evaluates to itself. I have 5, which of course evaluates to itself. And then I have 4 plus 5, which will evaluate to 9. So I have this addition operation I can perform. This is itself an expression. We know that it's an expression because when we run it here, we get an output down here. So the object 4 plus the object 5 gives us the object 9. So here, now we get x plus y, where x and y are whatever the arguments happen to be. We add them together and store the result in a variable called z. So that adds them together. In fact, let me clear out these comments, put them in the right spot here. Whoop. And now all we have to do is display the result. And we've already seen how we display the result. Print. So print, and what do I want to print? Well, I would like to print z. So whatever object I named z, that is the object we want to print. And that's how we're going to display the result. Okay, so we now have our add.py program put together. Oh, incidentally, if you're in the Python interactive shell and you want to get out, you can call the exit function, just like this. And that will exit. So now that we have our add.py program put together, let's give it a shot. So let's add the numbers, how about 3 and 7? So when I hit enter, what's going to happen is this is 3 and this is 7, which means that x is going to equal 3 and y is going to equal 7. Z will be assigned the value of 3 plus 7. So 3 plus 7 is 10. So Z will refer to the number 10. So when we print Z, we should see the number 10. And that is not at all what happens. So why do we see 37? So if you look at our inputs, 3 and 7, and you look at our output, 37, I'm sure you can see the, the not so subtle pattern. What's happened is our program has taken the number 3 and it has taken the number 7 and it has stuck them together. This is something called concatenation. Now, why did it stick them together? When if I did this, even if I said x equals 3 and y equals 7, if I evaluated x plus y, I get 10. So why is it that in my interactive shell, I see 10 when I do this, but up here, I see 37? Well, the reason for this is that a program needs to be able to process different kinds of information. And different kinds of information are going to have to be represented differently on the computer. This should make sense. If you were to drill all the way down to the most fundamental level of interacting with computer hardware, right, everything is represented in binary. You have 0 and you have 1. Those are really the only two things that a computer knows how to represent, or 0 and 1. But as it turns out, you can take zeros and ones and string them together in a variety of different manners to represent any host of things. You can represent numbers, letters, pictures, music, all of that. It's honestly kind of a miracle if you think about it. The problem is that each one of those things is going to be represented differently, right? The number 1 is going to be very different in representation from the word hello. And so our computer, and by extension Python, needs to have some way of knowing what representation it should be using. How should it interpret a particular string of zeros and ones? Should it interpret it as a number? Should it interpret it as text or a picture or a date or any number of other things? The way that it does this is using something called a data type. So every object in Python, every piece of data, is going to have associated with it a data type. And this data type is going to define the way in which Python interacts, or Python allows you to interact with this data. For example, this plus sign, the way this plus sign behaves is defined by the data type of the things that I'm applying the plus sign to. So whatever object X refers to and whatever object Y refers to. They have a data, those objects have a data type. That data type tells us what this plus sign does. So here, obviously, our plus sign is behaving as we would expect. 3 plus 7 is 10. Here it's not. So let's look a little into our data types here and see if we can figure out what is going on. Let's fire Python up again. So there are a couple of really commonly used basic data types in Python, and I'm just going to quickly breeze over them all. Each one will have opportunity to be talked about extensively as we proceed. So the most commonly used ones are going to be integers. So for example, the number 1 or the number -15 or 25. These are all examples of integers. And an integer is just a whole number. We also have a data type that we can use to represent numbers that have a fractional component, say 3.5. And that is what's called a float. And we've already seen text. This is what happens if you miss a quotation mark on the end of text, by the way. So you get this error. But this is what we've already seen this text. This is what's called a string. Additionally, Python actually has true and false as well. That is something called a Boolean. So if you're ever in doubt as to what data type a particular thing is, you can easily check by using a Python built-in function called type. So if I call the type function and pass in as input some object. So remember, an expression evaluates to an object, so I can put any expression I want inside of here, and it will tell me what data type the object that expression evaluates to is. For example, if I said the data type of 5, that is an integer, or int for short. If I did 5.6, we now have a floating point number. I can get the type of true, and that is bool, which is, of course, short for Boolean. And I can get the type of hello, and that gives us a string. Because I can put any expression I want in here, and let me just clear my window here, I can also do something like this. If x equals 6 and y equals 9, then what is the data type of x? X is an integer. How about y? Well, y is also an integer. What x plus y? Any idea what that data type is going to be? That's also an integer. 6 plus 9 gives you 15. 15 is an integer, right? While we're at it, you can put, because you can put any expression in here, one thing I want to point out is, and this is something we're going to not really talk about a whole lot for a while, but I should point it out right now. What is the data type of print? So print, as you'll recall, is the Python built-in function for displaying text. We see it right here. And when we talked about calling functions, we said we have a function, which is referenced by a name. And then we can call that function, we can execute the code by applying these parentheses to it, right? But print itself is just a name. It's really no different from x, z, or y. So, what data type do you think print is? It's a function. Specifically, it's a built-in function, so it says that, but print is a function. Kind of cool, right? The implications of that are enormous, and we'll have occasion to take advantage of this sort of thing quite extensively later. For the moment, though, let's turn our attention back to the problem that we're having. So we're evaluating x plus y, and rather than getting 15 in this case, we're actually getting 69, or whatever the case may be. So let's see if we can replicate it here in the shell to get an idea for what our data types are. So we're entering 6 and we're entering 9, but we're obviously not getting integers. What if we use strings? I'm going to go with 6 and y equals 7. So if I evaluate x plus y now, we get 67. Not 13, as we would expect. And therein lies our problem. Let's take a look at what the data type of x and y are. So rather than displaying the result alone, I'm also going to display the data type of x. I'll display the data type of y, and I will also display the data type of z, like this. So we'll get the result of our addition plus the data types of all three things when we run this program. So let's go ahead and add 3 and 7 together. So we get 37, and then str, str, str. str is, of course, short for string. Okay, so we are working with text. Python thinks that the numbers that we are entering are text. And when Python sees text and you apply a plus sign to it, it sticks the text together. And that makes some semblance of sense. If I were to say hello plus world like this, just looking at that, what do you think is going to happen? Well, it sticks it together. We get hello world. Takes two strings, combines them into one that's stuck together end to end. That operation, by the way, is called concatenation, if you're curious. Big, long, scary word. So, yeah, that's a problem. Because if we want this calculator to work, we have to convert convert our inputs into numbers so that the addition actually works. How might we do that? Well, Python, as luck would have it, or design would have it perhaps, has built-in utilities for converting objects from one data type to another. As I'm sure you would imagine, it is fairly common to want to take some numbers off of the command line and convert them from the default string into actual numerical data so that you can do math. So let's do that. If I have, say, y equals 7, right? Y is a string. If I want to convert that into an integer, note if I evaluate y in isolation, it comes out in quotes, it's a string. If I want to convert that to an integer, I need to use the int built-in function. So int will accept as input some object, and it will take that object and attempt to change it from a string into an int, or from whatever data type it is into an int. So note, quotes are now gone. Those are gone. It is just 7. And we can evaluate, let's store that as x equals int y. So the data type of x is int. Note, however, that the data type of y is still string. This int conversion is not altering y. It simply evaluates to an object that is y treated as an integer. So y is unchanged. It gives us something new, and we can assign it if we want to use it. So int is what we want over here. Now, what is it that we would like to convert to an integer? Well, x and y. And there's a couple of different places in this program that we could do this. The way that I'm going to do it is this. We have this sys.argv1 and sys.argv2 lines, which are actually obtaining the argument from the command line. So let's just take this and run this through my integer conversion before we even bother assigning it to x. So what'll happen is I'm going to say int sys.argv1 and int sys.argv2. So how is this going to actually work? Well, when you're dealing with functions and these parentheses, what's going to happen is it's just like evaluating math. If you think to your algebra classes or whatever, however long ago that may have been, you're going to start on the inside of the parentheses and evaluate the expressions in there. So here we have sys.argv1. This is an expression which will evaluate to the first object or the first argument passed into the program when I run it. So I'm going to get the first argument here, and then that first argument gets run through the integer conversion function, so it gets turned into an integer object, and then that integer object is assigned the name x. And we do the same thing here to get y. So now that I have done this, if we save the program and we run it, and I'll go with 7 and 3 again, or 3 and 7 I think is what I had done. Now notice we have 10, which is correct, and our data types are int, int, int. So x is now an int, y is now an int, z is now an int. Now you'll notice that at no point here did I define what data type z is. Python figures it out on its own. So that's one of the neat things about Python, is that it will figure data types out for you. You don't specify them like you would in many other programming languages. So we convert this to an int, we convert this to an int. Those two data types are more or less explicit, right? The word int shows up here. And Python just knows that if I'm going to take an integer and add them together, the result will be another integer. So it assumes correctly that z should also be of type int. Now I'm going to go ahead and get rid of these extra print statements, which leaves us with our program. And we now have a program that does this. And the question is it complete? And the answer to that is possibly not. One thing you have to do when you're writing a program is, even once you've more or less solved the problem, you have to test it to make sure that it actually does what you think that it's going to do in every situation. So let's test this on a variety of different inputs and see what happens. So obviously if we give it numbers, it works. Works great. What happens if we instead give it A and B? What if we give it letters? We get an error. Now, does this error make sense? If you think about that, I think you'll find, yes, this particular error does make sense. We'll have a calculator thing to add numbers together. If we give it something that is not a number, it won't be able to add them. So the fact that it throws this particular error here for letters is fine at this point. Later, we'll learn how we can actually capture and handle these errors in an elegant way that doesn't result in ugly error messages getting displayed. But for now, this is fine. This is perfectly fine. Another thing that you might try is, what if I wanted to add 3.2 and 7.8, for example, which should give us 11. What's going to happen here, do you think? So before I even run it, let's ask this. 3.2. Is 3.2 a valid integer? Well, what is an integer? An integer is a number with no fractional component, no decimal point. We have a decimal point here. So 3.2 is not an integer. So at the very best, what will happen is we'll get some number that perhaps is not actually 11. At the worst, we'll get an error. Let's find out what happens. We get an error. Invalid literal for int with base 10, 3.2. Basically, the integer conversion function sees this decimal point, which isn't a valid character for an integer number, and throws a fit because it doesn't know what to do with it. So let's see if we can fix this problem. What if, rather than converting to an int, we converted to a float? So a floating point number is a number with a decimal point. So it stands to reason that if I said x is equal to 3.4 as a string, if I say y is equal to float x, A, that shouldn't error out, that makes sense. B, the data type of y should be float, and C, the actual value of y should be 3.4. All of that works. So if we use float instead of int, then this thing will work for floats. The question is, will it still work for ints? Well, one of the great things about programming is it usually costs nothing to try something out. So you don't have to sit here thinking about it for a while to try and work through it. You can just do it. Let's make x equal to just the number 5. So if y is equal to float x, will we get an error? No, we do not. What is the data type of y? The data type is float. What is the value of y? 5.0. Now, the astute among you might notice that 5 and 5.0 are different things. Right, 5 is an integer, 5.0 is a float. But mathematically speaking, they're basically the same. So we can convert from an integer into a float without actually losing any information. We can just add a 0.0 and we're good. Now, floats do have some intricacies as far as working with them that will come up later. But for now, we can almost consider the integers to be a subset of the floating point numbers. Obviously, that's not technically true, and the representations are very different. But from a practical standpoint, in this application, it will work. And so let's try it. Rather than saying int over here, let's make them floats instead. It's a very, very quick and simple change to make. And let's give this program a run. So first of all, let's make sure that if I give it 2 floats, it actually works. And sure enough, it does. What if I give it 2 ints, say 5 and 8? It still works. What if I do an integer and a float? It also still works. So that seems like we're in good shape. And of course, if I give it a letter then it's going to throw a fit because it can't add letters. Letters are not numbers. So that also makes perfect sense. One other thing to point out is that it's important, because this thing takes 2 arguments, we have to make sure that we actually give it 2 arguments. So if I call it with just 1 argument, even if that argument is valid, we will also get an error. We'll get that index out of range error that we saw last time when playing around with the index on argv. So we'll want to be careful of that, make sure we give it both things. And again, this error is fine right now because if our program doesn't have enough data, it won't work. So the fact that it throws an error in that case makes sense. Later, we'll figure out how to fix that particular error as well. So there we go. That's probably a good stopping point for this video. What we've done is we've created a very simple non-interactive calculator, which allows us to specify 2 numbers, be them integers or floats, add them together, and display the result on the terminal. And we did this by using sys.argv and converting the data type of the arguments from string into float. Then we use the plus sign to add those together, and we print the result. And along the way, we discussed and were introduced to the concept of a data type, the concept of an expression, the concept of assignment, and the concept of a variable. So there was a lot of new conceptual material packed into this relatively simple program. And at this point, you're actually in a position where you can start to do some really cool and interesting things. So in the next video, rather than going over any new content in particular, we're going to work through a slightly more complicated example of a command line based program like this that we can write using the programming information that we now have. So I hope that you found this video useful as always, and I will see you in the next one.